So when you are learning data science and AI and you want to transition from your current role into role of a data scientist, one of the factors that you should ensure is you are building domain specific projects. So let's say that you're someone having 5 years of experience in automotive industry and now you are learning data science and AI to become data scientist. Then what you should do is when you are building projects, you should build at least 2 projects which are related to the automotive industry. Because if you do that and if you then apply for data science roles in the automotive industry or any consulting company which is consulting automotive client or any IT service company, then there your experience as in the automotive industry would be counted. Then you have built the projects related to automotive industry that would help you to get shortlisted for the interview. And during the interview, you can talk about those projects. Those projects would be relevant industry problems for that particular industry. So it would help you in getting shortlisted as well as for cracking the interview. So make sure that you are building domain specific projects. So what we have done is we have built 7 projects related to different industries and domains. So like financial domain, automotive domain, manufacturing domain. So all these different domains we have covered, and there are 7 projects which are covered in this particular video. So go through these projects, try to build these projects on your own, and then you can add them on your CV. So let's get started. In financial domain, we can apply data science and AI for solving multiple problems. So for example, if we are a company which is giving credit cards to the customers, right? Then we can use historical credit card data of people who took the credit card and then paid all the payments on time, and people who took the credit card and didn't pay payments on time, right? And then use that data to train our machine learning model for predicting future credit card defaults for any new credit card application. Similarly, all the fintech companies which are instantly approving the loan as soon as you submit your loan application, they are using data science and AI for predicting the chance of loan default, and then basically according to that, they are taking decision whether to give loan to this particular person or not. Then when you invest in multiple products, like for example in mutual funds or in stock market, then that investment can also be made personalized based on your credit history, based on your financial history, what amount of money you have, where you want to invest it, your risk appetite, and then based on that you can create a recommendation model which would recommend you portfolio across different sectors. So basically data science has application across multiple problem statements in finance, and what we would do today is we would build an engine or a machine learning model which would predict whether to give loan to this particular person or not. Let's get started. So at the beginning, we are importing all the libraries which we need. So we are importing NumPy, Pandas, and then from scikit-learn, which are functions and models which we need, we are importing them. And along with that, we are also importing the visualization libraries. Okay. So in terms of the data that we have, it's a historical data related to the loan applications. So this is a quick snapshot of the data. So we have information about loan ID, then the gender of the person who has applied for loan, whether the person is married or not. Then we also have information about number of dependents on that particular person, educational background, whether the person is self-employed or not. Then we also have information about the income, because whenever we want to give loan to anyone, right, it is very important to know what kind of income that person has. Then we also have co-applicant income. Then we have information about the loan amount which is applied, the information about loan amount term, what's the term for which that particular loan has been applied. Then information about whether we have credit history of that particular person or not, and that person is coming from urban area, rural area, or a semi-urban area. So the property area information also we have. And then at the end we have a loan status column which is yes or no, so whether the loan was sanctioned to this person or not. So this is the information we have related to the loan applications, and in total we have 614 loan applications for which we have the data. Now what we would do is we would try to build a machine learning model which can automatically predict based on the data whether this loan application should be sanctioned or rejected. Okay. So the initial step that we would do is we would explore the data. We'll try to understand the data before doing any machine learning modeling. So here what we are doing is data frame df.info. So that would give us information about the data frame. So these are all the columns which we have. And if you see, we are also getting the number of non-null values. So in loan ID, we have 1614 non-null values. So basically we don't have any missing values. In gender, we have 601 non-null values. So there seems to be some missing values in gender column. And similarly in dependents also, we have few missing values because the non-null values are just 599. So these initial columns, if you check their data types, it is object. So basically these are categorical columns. We have information in the form of predefined categories. Then we have applicant income column where we have information in the form of integer. Then we also have information regarding co-applicant income, loan amount term. So that information we are getting in the form of float. And then at the end, we are also getting information regarding the loan status, whether the loan was approved or not. Then using describe command in pandas, you can check the information for every column. Specifically here, we are checking information for all the numerical columns. So what we are doing is data frame name dot describe. So that would give us information about all numerical columns in that particular data frame. So basically with respect to applicant income, the average value which we have is 5403 and the minimum value is 150 and it is going all the way up to 81,000. Then co-applicant income, the average value which we have is 1621 and the minimum value is 0 and it is going all the way up to 41,667. So this is basically the information that we are getting in terms of the loan amount term. The term for the loan, the average value is 342 and it is starting right from 12 months and going all the way up to 480 months. So basically 40 years. So this is how we have information regarding various columns. And now let's check what's the percentage of missing values which we have in every column. So what we are doing here is data frame name dot is na and then we are summing up the missing values that we are getting, multiplying it with 100 and then dividing by the total number of rows we have in DF. So this would give us percentage of missing values in every column. So over here, if you see in loan ID, we don't have any missing values. Then in gender column, we have around 2% missing values. Similarly for dependents column, we also have 2% missing values. Then whether person is self-employed or not, in that column, we have 5% missing values. And the highest number of missing values are in credit history, which is 8%. So basically we have few columns where we have missing values. So we'd have to handle those missing values before we go ahead and build any machine learning model. So in terms of the gender column, most of the data in this particular column is falling under male gender. And then we also have few female applicants as well. Okay. So this is what we have. So when you have data in the form of categorical columns, the most used methodology for missing value imputation is basically imputing the value using mode value. So mode value is the most occurring value in that particular column. So in this particular column, the most occurring value is male. So what we are going to do is wherever we have missing value in column gender, we are going to impute that value using value male. So what we are doing is df gender is equal to df gender dot fill na and then we are passing this particular value which we are getting. So basically mode value in column gender, which is basically male. So we are imputing the missing values in column gender using value male. Then the next column where we have missing value, it's column married. So if you see here, around 200 plus people we have which are not married and around 400 people are married. Now in this case, if you check again, the mode value for this categorical column would be the most occurring value, which is yes in this case. So what we are doing is we are imputing the value in column married using mode value, using a fill na method in pandas. So basically these are the simple missing value imputation strategies which we are using. But if you are working on a data where really data is missing for more than 10% of the values, right? And you are able to impute that data based on some other column, you can always think of those strategies as well. But if there is no such relation with other columns for imputing the missing values, then you can always go ahead with the simpler methods. Basically mode imputation for categorical columns and median imputation for numerical columns. So the next column that we have is dependents. So in terms of the number of dependents, around 350 loan applicants have 0 dependents, around 100 loan applicants have 1 dependent. Then we have few people with 2 dependents and more than 50 people with 3 plus dependents as well. So this is the data we have with respect to number of dependents. So if you check the number of dependents here, so for 0, 345, for 1, 102. So the most number of occurring value in this particular column is 0. So if you check the mode of column dependents, it is basically 0. So what we are going to do now is column dependents, we are going to impute the value, which is the mode value. So wherever we have missing value in column dependents, we are going to impute that with value 0. So again, we are using the mode imputation over here because this is a categorical column. Then the next column that we have is self-employed column. So in self-employed, around 500 people are not self-employed and around 100 people are self-employed. So in this, if you check the mode value that we are getting, it's no. This is the most occurring value in this column. So we are going to impute the missing values in column self-employed using the mode value. So again, we are doing the missing value imputation over here. So if you see here, now we are left with the 3 columns which are having missing values: loan amount term, and credit history. So these 3 columns are numerical columns and we are going to do the imputation for them using median value. So for numerical columns, you can either use mean value or median value for the imputation, but median value is impacted by the outliers. So if there are any outliers in that particular numerical column, your mean value would get impacted. That's why it is better to use median value for the imputation. So in terms of the loan amount, the median value that we are getting is 128. So we are going to impute that. So DF loan amount would be equal to DF loan amount fee lene, and in that we are passing the median value which would be imputed in this particular column. Then similarly for loan amount term, we are going to use the median value which is 360 for imputing. So this median value would get imputed in this particular column using again the fee lene method. And similarly for credit history, if we check credit history, in this case basically we have data in the form of category. So it is 0 and 1.0. So the mode value in this case is 1.0 because this is the most occurring value in credit history column. So we are going to impute that using this mode value. So we are using the fee lene method over here and passing it the mode value for column credit history, and that would basically impute the missing values. So if you check missing values now, in all the columns we have 0 missing values. So we have successfully completed the missing value imputation step, and now we can go ahead and build our machine learning model. Okay, so this is the data we have. Now if you see here, gender information is in the form of male or female. Then in married column we have yes or no value. Then in education column we have whether person is graduate or not graduate. So when we build machine learning models, most of your machine learning models would understand the data in the form of numbers. So let's convert the data in the form of numbers so that models can understand that data. So over here, the loan status is in the form of no and yes value. So what we are doing is we are going to replace this no value with 0 and yes value. So basically flag Y with 1. Then in gender, we are replacing male with 0 and female with 1. And similarly, we are doing this operations in education, married and self-employed column as well. So if you see in these columns, we have only 2 categories. So we can directly replace them with 0 and 1. If we had more than 2 categories, then we can create additional features basically using the dummies function, pandas dummies function. But here we have only 2 categories. So we don't have to create additional features. We can just replace the categories with 0 and 1. And loan status is basically the value which we are going to predict. So we are encoding that as well into a numerical format. So after we do this step, this is what we would have. So we would have information now in the form of numbers. Only thing now that is remaining is dependents that we have, which can be 0, 1, 2 and 3 plus. So 3 plus is basically a category. And we also have property area, which can be urban, rural or semi-urban. So even this is remaining still in the form of categories. But as there are more than 2 categories in these 2 columns, we would create dummy features for them instead of just replacing the values. So basically what I'm doing now is I'm creating a function here for training and testing data split and feature creation. So what this function would do is it would split our data into training and testing data set. Because whenever you build any machine learning model, it is very important to separate your training data and test data, because then you can train your machine learning model on training data and then evaluate it on your test data. So that's what we are going to do over here. So I'm calling this function train test split and features over here and passing it our data frame df. So this is the function, basically definition of that particular function. So what is happening in this function is we are creating variable y in which we are storing loan status. This is the column for which we want to build a predictive model. Then in X we are storing all the features, and obviously in that we are dropping loan status and loan ID, because loan status is the value which we want to predict. So obviously we cannot use it as a feature, and loan ID is just the unique number representing the ID of that loan application. So that is also not going to help us in building better model. So we are dropping that as well. Then as I mentioned above, for columns, property area and dependents, these columns have more than 2 categories. These features have more than 2 categories. So we are going to create dummy features for them using pandas get dummies function. So basically this would create a column each for every category in that column, and that column value would be 0 and 1 based on whether that category is present or not. So this is what we are doing over here. Then for train test split, we are using the train test split function from scikit-learn, passing our feature data, our y value, and we are keeping test sides as 0.20. So basically we are keeping 20% data for testing the model and 80% data for training the model. And after that we are just printing the data that we have, okay, and then saving all the features into variable features and returning everything over here using a return statement. So if you check now, this is how our training data is looking like. We have various columns, and every column is now in the form of numbers that we wanted. So if you see here, for dependents 0, dependents 1, dependents 2 and dependents 3 plus 4 columns were created. So basically a column for every category was created using pandas get dummies function, and every column would either have value 1 or 0 based on whether the dependents are 0 or not. Similarly, when none of the dependents are equal to 1, this column value would be equal to 1, otherwise it would be equal to 0. So this is how now we have created our feature matrix for building a machine learning model. Now next step that we are going to do is we are going to actually build the machine learning model that we want. So what we are doing over here is we are creating a function fit and evaluate model, and then passing it our training data frame, testing data frame along with corresponding labels. Now let's see what is happening in fit and evaluate model function. So this is the function basically which we have. So in this particular case, I'm using a random forest classifier. So you can use any kind of model. You can use XGBoost, neural network, support vector machine, or even logistic regression. But whenever you build any model, make sure that if there is no such requirement to start with complex model like neural network, or if there is no such requirement to start with simple model like logistic regression, you use some form of a non-linear model. So usually I recommend people to start with random forest or XGBoost model, because these models are really good in capturing linear as well as non-linear relationship between input and output, and these models also give really good results on most of the data sets. So you can directly start with them. One of the mistake that I have seen many people who are learning data science and machine learning first time they do is whenever they get regression problem, they start with linear regression, and whenever they get any classification problem, they start with logistic regression. But don't do that, because those models can capture only linear pattern. But in this case, we want to capture linear as well as non-linear pattern, because we don't know what kind of pattern is there. So it is better to go ahead with non-linear models. So what we are doing is we are initiating a random forest classifier. We are keeping the maximum depth of the trees equal to 5. So this would create trees which would be having maximum depth 5. Then we are keeping the min sample split 0.01. So basically this is the threshold for splitting the tree. So there should be at least 1% samples available for splitting or creating any new split in the tree. So this is that threshold, mean sample split. Then we are passing another threshold, max features equal to 0.8. So it means that whenever there is any tree created at any node, only 80% of the features would be used for evaluating the split. So the max features equal to 0.8 basically represents that we are going to use only 80% features max for creating any split or evaluating any split at any particular node within a tree. And then we are keeping max samples equal to 0.8. So this is related to the bagging concept within random forest. So max samples 0.8 means for individually building any tree. So if you know how random forest works, we are going to build multiple trees parallelly. So every tree would be using only 80% of the data in terms of the total training data that we have. So within that also we are going to use only 80% data. So this is called as basically bagging concept within random forest, and it helps in avoiding overfitting. So we are keeping max samples as 0.8. Then we are initiated the model over here, and then we are applying the fit function random forest.fit, passing it our training features along with the labels. And then we are predicting. So after the model is trained, we are applying it on the test data. And that would give us basically the predicted labels. After that, we are creating a confusion matrix by passing it our test labels and the labels which we have predicted from the trained model. Then we are calculating the accuracy score. And after that, we are also basically printing the classification report, which would give us precision recall and all other values which we want for evaluating any machine learning model. So if you see here, this is the confusion matrix which we are getting. So how to read the confusion matrix? So basically first row is for class 0 and second row is for class 1. And this means that we are able to predict 14 samples correctly within class 0 and 19 samples we are predicting them as class 1. And when it goes to class 1, we are able to predict 87 samples out of the 90 samples correctly. And if you remember, in terms of which is class 0 and class 1, we did the encoding over here. So loan status yes is basically our class 1, and loan status no, that is N, is our class 0. So wherever the loan is approved, the class is 1, and wherever the loan is not approved, the class is 0. Now if you see here for class 0, we are getting precision of 0.82 and recall of 0.42, and overall F1 score that we are getting is 0.56, and for class 1 overall F1 score that we are getting is 0.89, and the accuracy of this random forest model is 82%. So basically we have built a decent model without doing lot of work with respect to hyperparameter tuning or anything else. So on top of that, now what you can do is we use these fixed parameters, right? So you can try different values of these parameters and do hyperparameter tuning using cross validation. That might help you to find better parameters which would improve the results slightly. Right. Then what we are doing is we are storing the important features that we are getting from a model. So if you do model.feature importances, that would give you the important features which are calculated based on how the features are used across the trees. That would give you importance of every feature. Okay. And we are storing it in a data frame importances, and then we are sorting the feature values over here based on the importance score. So this would basically give us all the feature importances. So every feature and its corresponding importance. This helps in better interpreting the results that you are getting. So suppose you built your machine learning model and you are presenting it to stakeholders in the industry, right? They would ask you based on 10, 12 or 15, whatever number of features which you had, which features were really important in building that model. So you would be able to answer those questions based on these feature importances. So if you see, now what we are doing is we are plotting a horizontal bar plot using matplotlib and passing it our features and corresponding importance scores, and that would give us the feature importance plot. So if you see this plot, the most important feature is credit history, whether we have a credit history or not, then the income of an applicant, then what amount of loan the person is applying for, what is the income of co-applicant, then what is the term for which the loan is applied. So these are important features. So the way in which you have to read this graph is these numbers or this magnitude is telling relative importance of that feature. as compared to other features within that feature set. So these 5 I would say are really top features within this model. So if you try to drop feature credit history and build this model again, you would see that your overall results are not as good as the results you have right now, because these features are really important. Now, based on this feature importance graph, you would be able to have good conversations with your stakeholders. And when you think of a data science interview, right, on this project, you might get questions around how you explored the data, how you did the missing value imputation, then which kind of model you built, how you decided the hyperparameters. Then you might get questions around what is max depth in this particular case, what would happen if you keep max depth 20. So you should be able to answer those kind of questions. Then what would happen if you keep max features as 1 all the time, you are not doing any backing on the features, what would be the disadvantage in that case? So those kind of questions you would get on these projects, because interviewer would try to understand how you're understanding that particular project. Are you having complete idea end to end, or you have just built that project using what you know? Then you will also get questions around important features, which features are important, then how those important features were identified, because this would help you in better understanding of the overall project. Then when you get any predictions from the machine learning model, you can get predictions in the form of labels as well as probability, because ideally the predictions that you are getting from machine learning naturally, they are in the form of probability. So what we are doing over here is we are using model.predictproba. So predictproba is the function that you can use when you want predictions in the form of probability, and pass it your test feature matrix, and then in next line we are predicting the corresponding labels using the predict function. So if you see here, right, every prediction you have 2 columns. So the first column is basically probability for class 0, and second column is probability for class 1. So here if you see here, the probability for class 0 is 0.19, probability for class 1 is 0.805. So in this case, the predicted class by machine learning model for this loan application is class 1. That's why you see 1 over here. So basically, using machine learning models, you can get predictions at the probability level as well. Now, if you want to improve your results further, what you can do is you can also play with these probabilities. So based on the probability scores, you can decide what sort of threshold you want to keep, because it is not must that you have to keep your classification threshold at 0.5. You can use various other thresholds as well. So you might be maybe more concerned about applications which are high risk applications, and you don't want to maybe miss them. Then accordingly, you can play with your probability threshold and then see what kind of predicted label you get. So you can always decide what kind of threshold you want to use for predicting class 0 or class 1. And that decision you can also take based on precision recall analysis or precision recall curve, and see for various kind of thresholds what kind of precision recall value you are getting across the classes, and then make your decision. So I hope you are clear now in terms of like how you can use machine learning and data science in financial domain, because now we have a model which can tell instantly whether this particular loan should be approved or rejected. Now, if you can imagine, this kind of a model has clear application in fintech domain, where people are submitting their loan applications online through mobile app, and then instantly you would get approval or rejection based on the kind of data you have. So try to build now more models into the financial industry, because there is a huge number of data sets which are available on websites like Kaggle, and you can try to build your own machine learning models, and those would help you in gaining confidence. Thanks for watching the video, and I will see you in the next one. Bye-bye. In manufacturing domain, there is a large amount of data getting created with respect to manufacturing of various products. So we can use data science and AI in manufacturing for predicting the quality of the product which is manufactured. Then we can also use data science and AI for predicting the maintenance needed for the machines. Because what happens in manufacturing company is you have a large number of machines which are placed one after another, and if one of the machine goes down, whole manufacturing pipeline stops working. So it is very important to predict the need of maintenance ahead of time to avoid such issues and to avoid loss of output with respect to that manufacturing plant. Hi, my name is Rohit, and in today's video what we would do is, with respect to manufacturing domain, we would develop a machine learning model which would predict the quality of the item or quality of the product which is manufactured from that particular manufacturing plant. So let's build this model. So at the top, I'm importing all the packages and modules that we need. So we would need pandas, numpy, then seaborn for the visualization along with matplotlib. And then I'm importing other libraries or other functions which are related to the machine learning model development. So the data that we have is related to the quality rating prediction of the product which is manufactured, and the features that we have are as per following. So we have the temperature information. So this would tell us what was the temperature during the manufacturing process, because temperature is very important parameter in determining the quality of the product. Then the second information that we have is pressure. So this would tell us what was the pressure which was applied during the manufacturing process. Then we have a derived parameter, temperature into pressure. So this is just the multiplication of these two values, temperature into pressure. And this basically captures the combined effect of these two process parameters with respect to manufacturing. Then we have material fusion metric. Again, it is derived from temperature and pressure. It is calculated basically as the sum of square of temperature and the cube of pressure. So this is how this particular parameter is calculated, and it represents material fusion related measurements during the manufacturing process. Then we have material transformation metric, which is calculated by considering the cube of temperature and subtracting it from square of pressure. So again, this is a derived parameter, and it is insightful to understand the material transformation dynamics during the manufacturing process. And the last column that we have is the quality rating. So this is basically our target variable. This is the variable, or this is the column that we are going to predict using the machine learning model. And this quality rating represents what is the quality, what is the overall quality or the quality rating that particular product is getting. So basically, whenever there is a manufacturing going on in any manufacturing plant, every product goes through the quality inspection process, and then based on the inspection of that product, there is a quality rating given to that particular product. Now let's imagine that there is a factory which is, say, manufacturing lakhs of product on a daily basis. So it is very difficult to verify every product. So, and the quality of the product is dependent on the manufacturing process. So if you build a predictive model which is based on the manufacturing process parameters, is able to predict the quality rating of the product which is getting manufactured, then that would create a huge value for the manufacturing industry. So that's what we are going to build over to in this particular project. So let's get started. Okay, so this is the data we have. We are reading the data from the CSV file, and then I'm just printing the top 10 rows using head function. So we have information about temperature, pressure, then temperature into pressure, material fusion metric, transformation metric, and quality rating. So we discussed all these parameters already. So let's go ahead and explore the data. So using dataframe.info function, you are able to get information about all the parameters or all the columns in that particular CSV file or in that particular data frame. So here we can see that these are all the columns which we have, and we have around 4000 rows in this data set, and everything is basically having non-null values. So it seems that is in this data we don't have any missing values. Then if you apply describe function on a data frame, it would give you various numerical calculations with respect to every column. So if you check, for example, temperature, the minimum value of temperature that we have is 100 and the maximum is 299.99. So around almost 300 degrees Celsius. Then pressure is ranging from 5 kPa to 24 kPa. Then similarly for all the parameters, we are able to get the values. So this data exploration stage basically helps you in understanding the data, how the data is distributed. And if you see the quality rating, this is the variable that we are going to predict. The minimum value that we have is 1 and the maximum is 100. So right from 1 to 100, we can get any quality rating for the product that is getting manufactured. So here I am creating a histogram of the quality rating column, and in that I am giving 20 bins, and the color of the histogram I am keeping as blue. And this is how the histogram will look like. So if you see here, most of the products are in the bin 95 to 100. So most of the products which are manufactured are high quality products, but there are some products which also have low quality rating. And these products, when they go out in the market, obviously they would create a lot of issues for the manufacturer. So it is very important to predict their quality based on the parameters of a manufacturing process. Now let's check the null values. So using data frame name .isna.sum, we are able to check the null values. So we don't have any null values, or we don't have any missing values in this particular data. Okay, so now I'm creating the plot for detecting the outliers. So for detecting the outliers, or you can say potential outliers, we can use the box plot. So we are creating the box plot using Seaborn. So here what we are doing is, first of all, we are creating the subplots with 2x3 matrix. So basically we can create 6 plots in this. And then we are passing every column one by one: temperature, pressure, then the temperature into pressure column, material fusion matrix, and the transformation matrix. So if you see here, these are the plots we are getting. So this is how the temperature is ranging. So the median value for temperature is around 200. Then for pressure, the median value is around 15. And you see that potentially we don't see many outliers. So in temperature into pressure, there are some potential outliers, but still the number looks very small. And whenever you see any numbers which are going above this range or below this range, right, or any data points, those are potential outliers. Those are not like definitely outliers. So you should always validate them with your business to understand whether those are actually outliers or not. So in our data, we don't seem to have any outlier problem. So all the features that we have are numerical features. Okay. So let's check the correlation between the features by plotting the heat map, and to that heat map we are passing the correlation matrix. So this is how the correlation matrix is looking like. So if you see features like material fusion metric and material transformation metric, they have very high correlation with temperature, 0.97. Then between material transformation metric and material fusion metric, we have 0.98 correlation. So we have some features which are highly correlated. Now, if you are trying to build models like, say, logistic regression, then this highly correlated, or linear regression, then the highly correlated features might impact the results that you have. But for tree-based models, even if you have highly correlated features, you can still be able to handle those. And another thing is to make conclusion between which of the features to be dropped between the highly correlated features. Usually, I would recommend you to drop the features which don't have causal impact on the output. So if there are some features which are main reasons for driving the output, then obviously those features should be kept. And if there are features which are having mere correlation with some of the features, then you can drop those. But in this case, we don't have any domain knowledge, so we don't know, say, out of material fusion metric and material transformation metric, which of the features we can drop. So in this case, when you are not clear which features can be dropped and those are highly correlated features, then I would say it is okay to keep both the features and then build your model. And then based on the model, you can decide which of the features you want to keep. So we are going ahead and keeping all the features, but we have the knowledge now that we have highly correlated features. So when we go at the feature selection stage based on the feature importance, we can use this knowledge and drop some of the features. Okay. So the numerical features that we have are temperature, pressure, temperature into pressure, material fusion metric, and material transformation metric. So we are now going to split the data into training dataset and testing dataset. So for that, I have written a function here, train test split data, and we are just calling that function over here. To that function, we are passing our data frame, which has data regarding features and the output value to be predicted. So we are creating a y variable, or we are creating a label column over here, which would have our quality rating. Then for our feature column, we are just dropping this quality rating because we don't want to use the value to be predicted as our features. So we are just separating our y and x variable. Then over here, I am just storing the list of all features which we have. And then using train test split function within scikit-learn, we are just separating the data into training dataset and testing dataset. So I am passing test size at 0.20. So basically we want to use 80% data for training and we would keep 20% data for testing purpose. So we are then getting our training data frame and testing data frame along with the corresponding labels. So we are just returning all the values over here so that we are able to get all those return values in these variables. So this is how our training data is looking like. We have 5 features in total and all the features are in the numerical format. Now in this stage, suppose you want to build a model like linear regression for predicting this numerical value of quality rating, right? Then I would recommend you to definitely use some form of scaling before you go ahead and build the model. What I have done is I have not used linear regression model. So I have basically used XGBoost model. So I don't have to use any kind of a scaling, because XGBoost is the tree based models, and for tree based models you don't have to use any form of scaling. Okay, so what I have done here is, first of all, I have defined the parameter grid. So I am going to try all different sets of parameters on my XGBoost regression model. So the parameters that I'm keeping: learning rate, I'm keeping 0.1, 0.2, 0.3. So learning rate in case of XGBoost model basically decides what's the contribution of every subsequent model that we are building in XGBoost. Because when you build XGBoost model, you are building models one after another, and every next model is trying to improve the errors caused by the previous model. So this learning rate decides what's the contribution of the next model in the overall result. Then the max depth decides what's the depth of the decision trees which are built in the XGBoost model. So we are going to try depth 3, 4 and 5. Then we have subsample information. So subsample decides what's the percentage of data we are going to use in every decision tree which is getting built in XGBoost model. So I'm keeping 80% and 90%. So passing 0.8 and 0.9 over here. Then call sample by tree. So this decides what's the percentage of features we are going to use in every decision node. So again, we are using 0.8 and 0.9, and number of estimators. So we don't have a huge data, very small data that we have. So I have kept the number of estimators as 50, because sometimes when you use large number of estimators, when you have small data, there is a chance of overfitting. Okay. So we are initiating the XGBoost regressor model over here. And then we are using the grid search CV function from scikit-learn model selection. And to this function, we are passing our model. Then we are passing our parameter grid, which we have defined over here. Then we are passing CV equal to 5. So basically, we are going to use 5-fold cross validation. And the scoring mechanism we are passing is the R2 score, because we are going to build a regression model. So we would use the R squared score for evaluating the performance of the model on different parameters, so that we can find which parameter set is giving us the best results on this particular data. So if you see here, you would see bunch of outputs over here. So basically, if you see these 5 selections, cross validation for set 1, set 2, set 3, set 4 and set 5. So what happens in case of a cross validation is your training data is divided into 5 sets, and in every iteration 4 data sets are used for training, and one of the data set is used for evaluating the model. So this is how in cross validation you are using different sets of data for training and evaluating in every iteration. So if you see here, for 5-fold cross validation, we are getting the results for every set of parameters that are tried. So I won't go through this because it is a bit unreadable. What you can do is, once you run this particular function, or once you run this model training part, you would be able to get results for all set of parameters into CV results variable within the grid search that we are initiating over here, grid search object. So what I am doing is I am storing that result into data frame, and then we are just sorting the result based on the mean test score. And we are keeping ascending false so that we get the best result at the top. Okay, so if you see here, so there are a couple of parameters for which we are getting very high result. So the mean test score that we are getting is almost 0.999. Then we also have some other parameters for which the results is still good, but bit less than the top result that we are getting. Now if you get these kind of results for various sets of parameters which are tried, so in this particular data frame, if we go here in column params, you would see that various combination of parameters are tried on this data. And then for every parameter, we are able to get set of results. So if you want to get the best parameters, you can just use the best params variable from this particular object that you are creating. So we are doing search best params. So the best results that we got on this particular data set were based on these parameters. So call sample by tree 0.8, then learning rate 0.2, max depth 5, number of estimators 50 and subsample 0.8. So we have found that these are the best parameters on this particular data set after doing hyperparameter tuning. Now what I am doing is I am now training the regression model on complete training data set that we have, and to this regression model now I am passing the best parameters that we have got. So these are the best parameters which we got, and I am just passing them over here, and then I am training the regression model using fit function on the whole training data set that we have. And then in XGB predict we are storing the prediction of the model that we have trained. So here we are passing the test features, and based on the model that we have trained we are predicting the value and storing it into XGB predict. Then after that we are calculating the R squared score or R squared value. So for that you have to pass your label along with your prediction, and if you see here the R squared value that we are getting is 0.999, which is very high value. So we are able to predict the quality of the manufactured product, you can say, with a very high confidence, with a very high accuracy. And in terms of the error, the mean absolute percentage error that we are getting, again you can calculate it using a function. To that you have to pass your label and the corresponding prediction that you have. The percentage error that we are getting is very small, 0.001. So we are able to predict the quality of the product which is manufactured based on the manufacturing parameters with a very high confidence or very low error. Okay, now what I have seen is most of the people who are learning data science for the first time, they stop over here, but they are not able to trying to understand which features are actually driving these results. So what you should always do is go ahead and try to find the important features. So for that, in the XGBoost model, you can use the model.featureImportances parameter, and that would give you importance score of every feature. And this importance is calculated based on how that particular feature is used during building decision trees behind the XGBoost model. So over here, we are just storing the important score that we are getting from features into a data frame. We are just naming the columns so that they become more readable, and then we are sorting the importance scores simply and printing all the importance scores. So in this case, we have only 5 features. So if you see here, this is the importance that we are getting. We have kept the importance in ascending order. So the lowest importance is given to feature pressure. It is 0.000047. And the highest important feature that we have is temperature. So it has 0.70 feature importance. Then material transformation matrix, it has 0.29 feature importance. So if you see here, basically material transformation matrix and temperature, these 2 features are completely driving the results of our regression model. And the remaining 3 features are having very small feature importance, or you can say very small contribution in our overall result. So if I plot the feature importances using matplotlib, this is how the graph is looking like. So temperature and material transformation matrix are the features which have very high importance, and remaining features have almost 0 importance. So they are not contributing to our overall result of prediction. So what you can do in this case is, if you have features which are having almost 0 importance, you can drop those features. You don't have to use those features in your machine learning model, because those features are anyways almost not getting used, and there is no point in building complex machine learning models. So whenever you use a large number of features in any machine learning model, that is making that model complex. And if those features are not bringing in any intelligence, why to use those features? So what I'm going to do now is I'm going to drop these remaining 3 features, and we are now going to build a machine learning model using only temperature and material transformation matrix, these 2 features. And let's see that using these 2 features, can we still get the results, the kind of quality results that we were getting. So what I am doing over here is, in our training feature matrix, I am taking only 2 columns, temperature and material transformation matrix. And in our testing feature matrix, again we are taking only those 2 columns, only those 2 features which were very, very important in this case. So remaining features, they are almost having 0 feature importance. So that's why we are dropping those features. And then I'm retraining the model over here using those 2 features, and I'm keeping the model parameters as the same. So whichever best parameters that we got after hyperparameter tuning, I'm using those parameters itself for training this regression model. And then we are just predicting the result after doing training on this new data set. So if you see here, the R2 score that we are getting now is still 0.999. So we are still able to get very high quality result along with very low error even after we are using only 2 features. So this is what I would recommend you. If you're having features which are almost having zero importance, you can drop those features and make your machine learning model less complex. And after using that less complex model, if you're still getting high quality results, that's the really great thing. So if you see here, I'm checking the feature importances again based on the new model that we have built. So over here now, if you see, temperature is having feature importance 0.608 and material transformation matrix is having feature importance 0.391. So just based on these 2 features, we are able to build high quality model which is able to predict the quality of manufacturing, quality of the product which is getting manufactured through that particular plant based on the various manufacturing parameters. And if you see here, right, we were having issue with some features having high correlation, but we went ahead with it. We still built our model, and after building the model, we are able to find a way to drop the features, and then we ended up basically with just 2 features which are able to predict the quality. Okay, so I hope that now you got good clarity in terms of how we can build regression model using XGBoost and specifically use that in a manufacturing domain. Because in manufacturing domain, one of the main reasons or one of the challenges that manufacturers are facing is the quality of the product. So if the quality of the product which is manufactured is not good, then that creates a lot of loss for them. Now let's imagine that based on these parameters, if you are able to predict quality of the product, maybe you can also predict what is the optimized parameters with respect to temperature and pressure to get high quality product as the output. And those parameters maybe then can be used by the manufacturers for making sure that their manufacturing pipeline is set in the right way. Now go ahead and try to build products or try to build projects using other datasets on Kaggle related to manufacturing domain. And specifically, if you are someone who has working experience in manufacturing domain and now you are trying to transition into data science, I would definitely recommend you to build at least 2 projects related to manufacturing, because when you apply for data science roles in manufacturing company and you already have experience in that domain, you would definitely get the advantage. Thanks for watching the video, and I will see you in the next one. Bye bye. In healthcare domain, we can use data science and AI for various use cases. So for example, using data science and image processing, we can predict whether someone has cancer or not based on the image data. Then we can also use data science for faster and better drug discovery using historical data. Then if we have information about health parameters of a person, then we can use those informations and data points for predicting whether someone has diabetes or not, or someone would suffer with diabetes or not in future. So all those kind of problem statements and questions related to healthcare domain can be solved using data and data science. Hi, my name is Rohit, and in today's video, we are going to build a predictive model which would predict whether someone would suffer with diabetes or not. Let's get started. So at the top, we are importing all the libraries that we need. So we are importing the NumPy and PyDAS library. Then from scikit-learn, we are importing trend test split function. So in this problem, we are going to build random forest classifier. So I'm importing that. Then all the metrics that we need for evaluating our model, we are importing those metrics as well. Then for hyperparameter tuning, we are going to use cross validation and grid search. So we are importing that function. And then we are importing the functions or modules that we need for visualization. So this is the problem statement for predicting whether someone would suffer with diabetes or not. So predicting the chances of getting diabetes in future. So in the first step, we are reading the data. So the data is present in the form of CSV. So we are reading it using the read CSV function in pandas. And then I'm just displaying the top 10 rows over here. So if you see here, we have first column, which is the ID of the patient. Then we have a number of pregnancies. Then we have information about the glucose level, blood pressure, skin thickness. Then we also have information about insulin and BMI. Then we have information about diabetes pedigree function. So this function basically gives chances of getting diabetes based on your family medical history. Then we have an age of a person, and at the end we have an outcome column, which is 1 or 0. So 1 represents the person is diabetic or there is a chance of getting diabetes, and 0 represents it's a normal health parameters. So this is the data we have. Now let's go ahead and explore the data. So to check which all columns you have and the missing values, you can use the info function. So I'm doing df.info, and if you can see here, we have 2768 rows in our data set, and all the columns or all the data points that we have are not having any missing values. So everything is present in this data. So we don't have missing values problem in this particular data. Then using describe function, you can get important statistical parameters related to each column. So we are applying the describe function on our pandas data frame. So for example, if we check column pregnancies, the minimum value of pregnancies we are having is 0. And if you check the mean value, the average value of pregnancies we have is 3.74. Then we also have a glucose level. So for glucose level, the average glucose level is 121. And the minimum glucose is from 0 and it is going all the way up to 199. Then similarly for blood pressure, we have values which are going up to 122. So for every column, we are having various kind of values and their ranges can be known using the describe function. Then if you have to check number of missing values in any column, you can use is null function and then on that you can apply sum function. So that would give you number of missing values in any column. So in column ID, we have 0 missing values. So basically all the columns have 0 missing values. So we don't have any missing values issue in this problem. Then the outcome column on which we want to build our classification model. This is the column we want to predict. So if you apply the value counts function, you will see that we have almost 1800 people which are not having chances of diabetes and 950 odd people with diabetes. Now I am just creating visualization related to box plot. So in this visualization, it would be clear that what is the range of feature values related to people who would have diabetes in future and people who won't have diabetes. So what I'm doing is I'm creating a figure with size 2012 and then I'm creating subplots with 3 by 3 matrix. So in total in this we can create 9 plots, 3 plots in each row. And then I'm plotting box plots using Seaborn for every feature value that we have. So we are creating a box plots over here. So this is how those plots would look like. So for example, number of pregnancies is on the y-axis over here and the outcome on x-axis. So class 1 represents people having diabetes. So if you see here for people with diabetes, the number of pregnancies are on higher side as compared to people not having diabetes. Then glucose level is also on a higher side for people suffering with diabetes and it's on a lower side for people not suffering with diabetes. So like this, you can go through every feature and try to understand every feature before you go ahead and build your machine learning model. So usually when you work in the industry, after you create these visualization plots, you can discuss with your stakeholders that this is the visualization I am getting. Now what kind of conclusion I can draw from that. So this would help you in getting better understanding of the data, better understanding of the domain before you go ahead and build your machine learning model. So if you check age, so age is on a higher side for people having diabetes and it's on a lower side if you compare these two boxes for people not having diabetes. So this analysis, exploratory data analysis, is useful for understanding the data, to getting better understanding of every feature and how it might have impact on your outcome before you go ahead and build your machine learning model. Okay. So basically what we are going to do now is we are going to create a train test split so that we can go ahead and train our machine learning model. So here I am calling train test split and features function, which I have written over here. And to that function, we are passing our data frame. So basically if you check here, right, what we are doing is y variable we are defining as the outcome column. So this is the column we are going to predict. And in X, we are going to define all our features. So obviously we have to drop outcome column and we have to drop ID column. Because ID is just giving us patient ID, so it won't be useful in creating our predictive model. So we are dropping those two columns and the remaining columns we are keeping in variable X, which is basically variable which has all the features. Then from scikit-learn, we are importing train test split, and by using train test split, we are going to divide our data into 80-20 split. So 80% data we would keep for training and 20% data we would keep for testing purpose. And over here, we are just printing the rows of feature matrix that we have, and we are also printing the list of columns that we have. And all the features we are storing in variable features. So if you see here, this is the data we have, and these are our features: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, and age. So using these features, we are going to build a predictive model which would predict whether someone would suffer with diabetes or not. So we have now created separate data set for training and testing. So training data set we would use for training the model, and testing data set we would use for evaluating the model. So over here I have written fit and evaluate model function. So in this function, if you see here, I am going to use random forest classifier. You can try to use different kind of models as well. And usually what I have seen is some people also try to build logistic regression model on such kind of data sets. That is also fine. But generally speaking, logistic regression model can capture the linear pattern between input and output. So if you want to capture non-linear patterns, it is recommended to go ahead with non-linear models, right? Random forest, XGBoost. So here I am just defining our random forest classifier with the default parameters which we have defined over here. So max depth we are keeping 5. So this is the depth of decision trees which would be built in random forest. Then mean sample split I am keeping 0.01. It means that when any tree is split, at that point of time there should be at least 1% data points for creating that split. Otherwise no further splitting would be done. Then max features we are keeping as 0.8. It means that at any point of a node where the decision tree would be split, it should use maximum 80% features for creating that split. And then max samples we are keeping 0.8. So here it means that it should be using maximum 80% samples for creating the split. So this max features and max samples is related to bagging concept within random forest. So this you can say is a feature bagging, and this you can say is a data bagging. So basically in this function, then we are going to fit the model using our training data set. So that can be done using random forest.fit. So we are initializing random forest classifier over here. Then after that, we are going to predict the label. So that can be done using predict function. So you have to give the name of variable in which you are storing the model, and then apply predict function. Then after that, we are going to get a confusion matrix basically. So the confusion matrix is used for evaluating the model, the accuracy score. So all the evaluation parameters we are getting over here. So here I am just calling the fit and evaluate model function and passing it our training dataset and testing dataset. So it would go here and execute the code, train the machine learning model using random forest classifier, and give output related to various evaluation matrix which we have kept. So this is how our confusion matrix is looking like. So the way to read this confusion matrix is the values that you have at the diagonal are the accurate predictions. So the first row is for class 0. So for class 0, we are able to predict 326 samples correctly. 48 samples we are predicting as class 1. And for class 1, we are able to predict 144 samples correctly. But 36 samples, though they are belonging to class 1, we are predicting them as class 0. So the accuracy of this model is 84.83%. And this is how our precision recall is looking like. So for class 0, our F1 score is 0.89. And for class 1, our F1 score is 0.77. So this model is giving us decent results. And overall it is 84.83% accurate. And the F1 score is also good for both the classes. So we are getting decent results with this model. Now what we can do is we can try to improve the results of this model. So that can be done using hyperparameter tuning. So what we are doing over here is we are defining the parameter grid. So basically we are going to try these different parameters on our model and see if that helps in improving the results of our model. So we are defining max depth as 3, 5, 7, 10. So all these parameters model is going to try. Then again for mean sample split, we are defining the range of parameters which we want to try. So in this parameter grid, we have defined different kind of parameters which we want to try on our model and see if any of these parameter combinations gives us better results. So then what we are doing is we are creating a random forest classifier, okay, with default parameters, and then we are passing it to grid search CV. This is the function that we are importing from scikit-learn. To that you have to pass your estimator, that is the model that you want to build. So in this case, we want to build random forest classifier. So we are passing it over here. Then you have to pass your parameter grid, the grid that you want to try on for the grid search CV. Then we are passing CV equal to 5. So we are going to use 5-fold cross validation. So every data set that we are going to pass, so this training data set is going to get divided into 5 sets, And every time 4 sets would be used for training and 1 set would be used for evaluating the model or testing the model. This is what happens in cross validation. And for every iteration, different sets of parameters would be tried so that we try to find the best possible combination. So when you run this, you would see the results. So basically you would see different sets of parameters that are getting tried and what kind of results you are getting with respect to the scoring. So what we are doing now is all the results would be stored into the CV results parameter. So we are just saving those results into data frame now, into a data frame results, and then we are sorting the values. So we are sorting the mean test score in descending order. So basically so that we get the best parameters at the top. So if you see here, let me scroll to the right. So the mean test score we are getting 0.9250 as the best mean test score on our cross validation data set. Okay. And what are the corresponding parameters? Let's check that as well. So we are getting it for maximum depth 10, maximum features 0.8, maximum samples 1 and mean sample split 0.01. For this combination of features, basically we are getting the best results, or this combination of hyperparameters, we are getting the best results. So instead of checking it manually, what you can do is you can also get the best results using best parameter within your grid search CV. So what you can do is search.bestparams, and that would give you best parameters on this particular data set for the particular model that you're training. So these are the best parameters we are getting. Now what we can do is we can retrain the model on whole training data set that we have, and this time we can use these best parameters. So basically what I'm doing is I'm again calling the fit and evaluate model function, which we have defined over here, this function. But this time we are passing the parameters based on the best parameters which we have found. So what you can do is you can pass the best parameters that you have found to this particular function. So if you see here the results that we are getting, accuracy of the random forest, in this case we are getting 94.40%. So we are able to get much more accurate model using the hyperparameter tuning that we have done. And you can also check the feature importances of individual features. So you can do that using model.featureImportances. So this would store the importance of every feature based on how it is used for splitting the trees across different trees within random forest. Based on that, it calculates how important every feature is. So that feature importances we are storing in a data frame, and then we are just creating a visualization of it. So if you see here, the most important feature that we are getting is glucose, then BMI, then age. So from this, when you discuss these results with your stakeholders, you can discuss that based on these features, my model has taken decision that who is going to suffer with diabetes in the future, and glucose, BMI, age are the most important features in predicting whether someone would suffer with diabetes or not. So this is how you can solve problems in healthcare domain using data science. So I hope this was clear to you how you can build data science and machine learning models for solving problems related to the healthcare domain. Now what you can do is you can go to Kaggle and try to get different data sets related to healthcare domain and build your own machine learning model. So that would give you a lot of confidence in terms of problem solving using machine learning. Thanks for watching the video, and I will see you in the next one. Bye bye. Data science and AI has applications across the domains. So if you speak about automotive domain, automotive companies can use data science and AI for predicting the need of maintenance for the vehicles. They can use data science for predicting the need of maintenance for the machineries which are placed in the manufacturing unit. Because what happens sometimes is if some of the machines goes down, there is a loss of production in that manufacturing plant. Then they can also use data science for predicting demand, because demand forecasting is a strong use case for automotive and manufacturing companies. Hi guys, my name is Rohit, and in today's video, we would build machine learning model for predicting the need of maintenance for automotive engines. So we are going to build predictive maintenance models for the automotive industry. Let's get started. So at the top, we are importing the modules that we need. So we have imported NumPy and Pandas library. Then for visualization, we have imported Matplotlib and Seaborn library. Then for training the model train test split, we have imported the train test split function from scikit-learn. In this project, we are going to build random forest classifier. So we have imported that. And we have also imported the metrics which are needed for evaluating the classification model. So we have done the import operations in this particular section. So we are going to build a machine learning model for predicting the need of maintenance based on the health of engine. So in this particular project, we are getting various data points. So we are getting information about engine RPM. So that basically stands for revolutions per minute of the engine. Then we are getting information about lube oil pressure. So this is basically the pressure exerted by lubricating oil within the engine. Then we are getting fuel pressure, coolant pressure, then the temperature of the lubricating oil, which is again very important from the engine's health point of view. And we are also getting coolant temperature. So all these parameters we are getting related to the engine for every automotive engine that is in use. And we are going to use these parameters, the values of these parameters, to predict the condition of engine, to predict the need of maintenance. So the data that we have is a binary classification problem. So in this particular column, engine condition, we are getting the labels. So 0 stands for unhealthy engines and 1 stands for healthy engines. So we are reading the data from a CSV file, engine data.csv, using read CSV function from pandas. And then I'm just displaying the top 10 rows using the head function. So these are the columns which we discussed. We are getting the values for them and the corresponding label. So if you think of this model, this would be really useful for all the automotive companies. So if they start capturing data related to the engines which are in use, they can also build similar model for predicting the need of maintenance for any engine. So using info function, we can get to know how many data points we have and whether we have missing values. So if you see here, in total, we have 19,535 data points, or you can say 19,000 plus engines data we have. And all the columns have the values. So we don't have any null values. So everything is non-null. So it seems like already a good data. Using describe function, we can get information about various columns and how they are distributed or what are the statistical values related to every column. So if you see engine RPM, the minimum value for engine RPM is 61 and maximum is 2239. Then lube oil pressure, the minimum value is 0.03 and it can go up to 7.26 and the average value is 3.3. Fuel pressure, it can go from 0.003 all the way up to 21. Then if you see coolant temperature minimum value is 61 and it can go all the way up to 195. So this is how we are getting the information about all the columns using describe function. Then let's just check if we have any missing values. So you can check it using isNA function and we are just adding up all the missing values for every column. So if you see this, we are having 0 missing values across all the columns. So engine condition is the column which we are going to predict using our machine learning model. So if you apply value counts function from pandas on this column, you would come to know how many data points we have for each class. So for class 1, we have 12,000 plus engines and class 0, we have 7,000 plus engines. So just to reiterate, in terms of class 0 and class 1, class 0 is for unhealthy engines and class 1 is for healthy engines. So we have 12,000 healthy engines and 7,000 plus unhealthy engines. Now in this section, I am visualizing the data to identify how data is distributed and compare it across the classes. So basically we are using box plot from Seaborn for visualizing the data and I am creating subplots. So basically we are going to create 2x3 matrix and in each section we are going to have plots. So all the variables, all the features which we have in this particular classification model, we are going to visualize those features with respect to the value that we want to predict. So if you see here, engine condition. So basically engine RPM is on a higher side if you see this, right, the way to which you can read the box plot, this central line represents the median value. So median value for class 0 for engine RPM is on a higher side as compared to median value for class 1. So class 1 are your healthy engines and class 0 are your unhealthy engines. Then if you see here fuel pressure, so fuel pressure is bit on a higher side for healthy engines and bit on a lower side for unhealthy engines. So if you see all these features, you would see that apart from engine RPM, other features are more or less having similar ranges. Okay, so just by seeing this data, it looks like very challenging problem to separate healthy and unhealthy engines based on only the features which we have. This definitely looks like a stronger feature because there is a difference in the values for this feature, but remaining features are kind of having similar ranges for healthy as well as unhealthy engines. But this is a multi-feature problem, so we can still find out patterns which might not be present with respect to univariate analysis, but with respect to multivariate analysis, the patterns might still exist. Okay, so now we are going to split the data, and what we are doing in this case is we are calling train test split and features function, which we have written over here. Now in this function, we are passing our data frame df, which has information about the engine along with the label. So we are creating our y variable, which would be basically the engine condition which we want to predict, and x variable, which would be all our features. So in features, we won't be using the y variable or the column on which we want to do the prediction. So we are dropping that column from our data frame, and all other columns are our features. We have 6 features in total. Then we are using the inbuilt function from scikit-learn, train test split. To this function, we are passing our features data and our labels data, and we are going to split the data into training and testing data set. So I am passing test size 0.20. So this is going to create 80-20 split. 80% data would be present in training and 20% data would be present in testing. So we would train our model on our train data and we would evaluate our model on our test data. So basically these are the columns we have. Now in this particular project, we are going to build random forest classifier. So we don't have to scale the data. So data scaling is not really needed because random forest classifier uses decision trees at the backend, and decision trees are not impacted by scales of the feature. So even if you have features which are on different scale, it's not a problem for decision trees. So we won't do any scaling. But if you wanted to use, say, something like logistic regression model, then I would recommend you to apply scaling before building the model. Okay, so this is our fit and evaluate model function, so which we are going to use for building the model. So we are calling this function over here, and to this function we are passing our train and test data set which we created in above function. So if you go to this function, we are creating a random forest classifier. To this random forest classifier, we are keeping max depth 5. We are keeping the mean sample split 0.01. So it means that the maximum depth of individual decision trees which would be created within random forest would be 5. Then mean sample splits 0.01. It means that there should be at least 1% samples present at any node to split the tree further. Max features we are keeping 0.8. This is related to feature bagging. So at any node we are going to use only 80% of the features. And max samples we are keeping 0.8. So it means that at any node we are going to use only 80% of the data points for creating that particular decision tree. So this is related to the data bagging concept. So here we are fitting the random forest model using the fit function. To that we are passing our training data set and corresponding labels. And then we are creating the prediction here using the predict method. So name of the model .predict and passing it our test data frame. So our predictions would be stored in this particular variable. After that, we are creating a confusion matrix. So confusion matrix would need original labels which were present in y test. So these are our test labels and these are the predicted labels on the test data. We have created the prediction over here. Then we can also calculate the accuracy score. So that would also require both the labels, the actual labels and the predicted labels. And then we can also print the classification report. So classification report needs your actual labels and predicted labels. So we are printing or creating bunch of evaluations over here. So let's see what kind of results we are getting. So this is our confusion matrix. So values which are on this diagonal, so 507 and 2137, these are the accurate predictions. So first row represents the predictions for class 0 and second row represents predictions for class 1. So the overall accuracy that we are getting in this case is 67.67%. So our model is almost 68% accurate in predicting which engine is healthy and which engine is unhealthy. And if you see the precision recall score, so basically class 0 is for unhealthy engine. So on unhealthy engine, the precision is still okay, but the recall is very small. It's just 0.36. And overall F1 score for class 0 is 0.45 and class 1 it is 0.77. So this model is performing better in identifying the healthy engines as compared to identifying the unhealthy engines. So when you get such results, 68% accuracy, so this model is still useful because at least it would tell you which are the potential engines which are unhealthy without doing any manual inspections. Just by capturing the data, you can know which engines are unhealthy. But you can improve this model further if you get more information about the engine. So instead of getting just these 6 features, if you get few more features related to that engine, maybe what is the lifetime of that engine, from how many months that engine is running, because the older engines might be in unhealthy condition, right? So those kind of features we might have to add in this model when we work this model in the industry, and that would completely improve the results further. So when you work in the industry on any problems, always think of if you can add more features in that particular model to get better results. You can always try different models as well, but what I have seen based on my experience, your results would be improved by adding more features as compared to trying some other complex model. So after this, we are calculating the important features. So feature importance we can get using model.featureImportances parameter, and we are just storing the feature importance into a data frame so that it becomes much more readable. So this is the data frame in which we have stored all the feature importances. So if you see here, the first column is for importance score and the second column is the feature name, and this is in the ascending order. So the lowest importance is given to coolant temperature and the highest importance is engine RPM. So engine RPM is having importance of 0.636. So when we discuss these visualizations, I told you that there is a clear difference between class 0 and class 1 with respect to the distribution of the data if you compare two classes for engine RPM feature. So this feature was already looking like a strong feature for separating class 0 and class 1, but remaining features, the values are more or less comparable. So those were looking like a weaker features, and that's what we are finding in the feature importance as well. So the feature with highest importance is engine RPM. So in this step, we are now just going to visualize the data that we have with respect to feature importance. So I'm creating the horizontal bar plot, and to that plot I'm passing the feature names and the importances. So this is the feature importance. The highest important feature is engine RPM, then fuel pressure, then lube oil temperature, and other features are also contributing. So every feature is basically contributing to this result, but engine RPM and fuel pressure seems to be the top contributors. Right guys, so I hope you now have clarity in terms of how to build machine learning models specifically in the automotive industry. So tomorrow if you land a job in automotive industry as a data scientist, definitely think about this use case. So if your company is capturing data related to the engine parameters, you can build such model, and as I mentioned, in this model you can add much more features. So for example, adding how old that engine is, in which region that engine is operating, what is the type of vehicle that for that particular engine. So all those data points you can add and you can get better and better results on this particular machine learning model. Thanks for watching the video, and I will see you in the next one. Bye bye. For e-commerce companies, it is very important to understand their customer behavior and to predict which of their customers would result in churn in future. Because to keep the constant revenue, it is very important to retain your current customers and keep gaining the new customers as well. Hi guys, my name is Rohit, and in today's video, we would build customer churn prediction model using machine learning. Let's get started. Okay, so we are getting started with the project. So at the top of the project, we are just importing the packages and libraries that we need for building this machine learning model. Now let me talk about the data. So the problem statement that we have is customer churn prediction in case of e-commerce domain. So we want to predict based on the customer behavior whether this particular customer would churn. So what is meaning by churn? So churn means the customer would stop using the platform. So we want to predict such kind of a customers, because if you are able to predict that, we might be able to handle those customers better. We might be able to provide them better customer service, and we can try to retain them. So that's why it is very important to predict the customer churn for e-commerce companies. And I think it is applicable for all other companies as well. Now the data that we have is customer ID. So this is the unique identifier for every customer. Then we have information about tenure. So this is basically the duration in years for which the customer has been associated with the platform. Then we have information about the preferred login device of the customer. So this is related to the device which customer is using for logging into the e-commerce platform. Then the tier of the city where the customer is living. So it can be tier 1, tier 2, any kind of a city. So this is the information regarding distance between warehouse and the home of a customer. Because for example, if the customer is living near warehouse, he or she might be getting the orders delivered on time and might be like a happy customer. So this is again a potentially important feature. Then the information about preferred payment mode of that customer. Then what is the gender of customer, number of hours the customer is spending on the app, then how many number of devices are registered by that customer on the platform, then what is the preferred category of ordering the product. So which types of product the customer is ordering more. Then what is the satisfaction score based on the feedbacks received from the customer. So what kind of satisfaction score the customer is having. Then whether the customer is married or not, we have information regarding that as well. Then how many number of addresses the customer is using for delivering the product. So that is again another important information. Then has customer lodged any complaints in the past. So that is important feature which we have. Then how is the order behavior? So is the number of orders, or let's say the amount of order, increasing over time or it is decreasing over time. So that information also we have. Then number of coupons the customer is using. Then how many orders the customer has placed till now. Then dates since last order. So how many days since the last order. So generally people who are churn or people who are not able to or not going to return to our platform, you would see longer duration between the orders for them. And amount of cashback received by the customer. So we have all this information regarding every customer, and we also have a churn column which would indicate whether the customer is going to churn or not. So 1 would indicate the customer would churn. So basically customer would leave the platform, and 0 would indicate that it's a happy customer, the customer is going to continue with this. So this is the information we have now. Now using all this information, we want to predict the churn, and we are going to do that using machine learning model. So first of all, we are reading the data from the CSV file. So I'm using the read CSV function from Pandas for doing that. This is the data we have: customer ID, tenure, preferred login device, is it mobile phone or computer, the tier of the city, warehouse to home distance, preferred payment mode, is it debit card, UPI or credit card, gender of the customer, hours spent on app, then how many devices are registered, then what is the preferred order category, is it laptop, mobile or fashion or something else, what is the satisfaction score of the customer, what is the marital status, so is he or she married or not, number of addresses, complaints, order amount hike, whether the customer is using coupons or not, what is the order count, days since last order. So we have all this information basically in the data that we have, and we are going to predict the churn column, which would be either 1 or 0. To start with, we would do the exploratory data analysis to understand the data. So if I use the info function on the data frame, I would get the basic information about the data frame. So df.info, this is giving me the basic information. So in customer ID, so in total we have data about 5,630 customers. So customer ID, all the values are non-null. Then in tenure, there are some customers for which we have missing data. So all these data types we have basically. And if I use the describe function on my data frame, I would be able to know now some basic information. So for example, tenure, the minimum tenure is 0. So basically the new customer, and the maximum tenure is 61. And the average is 10.1. The city tier can be anything from 1 to 3. Warehouse to home distance, the average distance is 15 and it can range from 5 to 127. So like this, we have information about every feature. So if you go through this, you'd be able to understand how every feature is distributed. Now let's check if we have any missing values. So what I'm doing is I'm using isNA function on the data frame in which we have our data, and then calling a sum function so that we get how many number of data points are missing in every column that we have. So basically in tenure, we have 264 missing values. In warehouse to home, we have 251 missing values. And similarly, there are other columns where we have some missing values as well. So before we build machine learning model, we'll have to impute these missing values. So we will do that later. So in terms of the percentage, almost 5% of the data is missing in tenure. Similarly for warehouse to home, and for other 4 columns as well, around 5% data is missing. So generally what I recommend is, if you just have 5 to 10% of the data missing, right, you can use simple mode or median imputation based on the type of data that you have. But if you have say more than 10%, 20% data missing and that column is really important, then when you do the missing value imputation, you can think of any other method apart from this simple imputation method as well. So these are the columns in which we have missing values. Okay, so we have just listed down those columns over here, and we are going to do the missing value imputation. So what we are doing is we are imputing the missing values using the median value of the respective column. So we are using the median imputation for imputing the missing values. So after we do the missing value imputation, if we check how is the missing data now in the data frame that we have, so the percentage of missing values is now 0. Because all the columns in which there was missing value, we have imputed those missing values using the median value of the corresponding column. Okay, now here I am just checking different unique values that we have in every column. So customer ID obviously would have a huge number of unique values because every value is unique in itself. Then in tenure, these are the unique values which we have. So preferred login device, so it can be mobile phone or computer. City tier, the person can belong to tier 1, tier 2 or tier 3 city. Preferred payment mode can be debit card, UPI, CC, cash on delivery, e-wallet, again cash on delivery or credit card. Gender, female or male. Then number of devices registered, we have 1 to 6 number of devices registered. In terms of the order category, we have important categories here. So we have laptop and accessory, mobile phone, others, fashion and grocery. Then this is the customer satisfaction score. In the marriage information, the person can be single, divorced or married. Then we also have information regarding whether they have raised any complaint in the past or not. So all this information we are getting in the data. And the churn column, it has only 2 unique values, 1 or 0. So in terms of the preferred login device, most of the people are logging using mobile phone. So out of the 5,000 odd data points that we have, 2,700 people are using mobile phone for login. Some people are using computer and again some people are using phone. Now in this case, phone and mobile phone is the same thing. Okay, it's just the different way in which data is represented. So what we would do is, in the preferred login device column, we would change the phone value to mobile phone so that we are able to handle the data, handle the feature in a right way. So what we are doing over here is we are replacing phone with mobile phone, and that operation we are doing on the preferred login device column. So in the preferred login device column, we are going to replace phone value with mobile phone so that we get the consistent category. So after doing this replace operation, now if we check the category within the preferred login device, we are getting just 2 categories: mobile phone for almost 4,000 people and computer login for 1,600 people. So this would help us in using the features in a right way. Otherwise, we would have to create separate features for phone, computer and mobile phone. But these 2 categories are same. So it is better to merge them. Similarly, now what we are doing over here is in the preferred login device, we have information about mobile phone and computer. So we are now replacing mobile phone with 0 and computer with 1. So this would basically help us in creating a feature, because when we want to build a machine learning model, we want to convert these categories into numbers. So we are mapping mobile phone to 0 and we are mapping computer to 1. So we are now already having preferred login device information in the form of feature. Now, with respect to the payment mode, these are the different payment modes customers are using: debit card, credit card, e-wallet, UPI, cash on delivery, CC, and again cash on delivery. So basically this COD and cash on delivery is the same. CC is credit card, again CC and credit card are same. So it is very important to merge these categories so that again we are considering the features in a right way. So what we are doing is we are mapping CC to credit card now, and we are applying that mapping on the preferred payment mode column. So df in square bracket the name of column dot replace operation. So wherever we have CC in this column, it would be replaced by credit card. And after that, if we check the unique values, you would see that now we don't have the CC category, but the customers with CC are now added into credit card. That's why for credit card now we have 1774 customers. And we are doing the same operation related to cash on delivery as well. So we are replacing cash on delivery with COD, and we are applying that replace operation on the preferred payment mode column. And after we apply that replace operation, you would see that now cash on delivery customers are 514, because we have added COD and cash on delivery into single category. So this is very important, guys, before you build machine learning model, because if you do that, you would be using your features in a right way. Now with respect to gender, we have male and female gender. So we are just replacing male value with 0 and female with 1. So this is again to convert your categories into numbers for using them as a features. Then preferred order category. So in the preferred order category, again we have different kind of devices: laptop, mobile phone, fashion, mobile, grocery, and others. Now again here mobile and mobile phone is the same thing. So we are going to merge these categories. So we are mapping mobile to mobile phone, and we are applying that mapping on the preferred order category column. So after we do that, if we check the count, you would see that we won't have mobile category now. Mobile category was having 809 customers, right? So that has now shifted to the mobile phone category. So now instead of 1271, we have 2080 customers, which are mainly buying mobile phones. Okay, in terms of the marriage category, the unique values are married, single, and divorced. And churn, so around 4600 customers are going to continue. So the label for them is 0, and around 950 customers, their label is 1. So these are the churn customers. So before we build the models, let's visualize the numerical columns and see what kind of patterns we are seeing. So on the x-axis, everywhere we have the churn value, so whether the customer would churn or not. And on y-axis, we have the numerical features. And we are creating a box plot here. So we have created a figure with 4x3 matrix such that we can create in total 12 plots. And for every numerical column, we are checking its box plot with respect to the churn column that we have. So for example, tenure column. So on x-axis, we have churn. On y-axis, we have tenure. So here churn 0 means this customer has not churned, and churn 1 means this customer has left the platform. So basically, if you see, what we are doing is like for churn 0, the average tenure or the median tenure is 10. For churn 1, the median tenure is very less. So by seeing this box plot, we can say that customers which are with platform for a longer duration, there is a low chance that they would be churning in future. Then if you check number of devices registered. So for customers who have not churned, the number of devices registered are 3 to 4. But there is lot of variation in customers which have churned. So they have large number of devices registered on the platform. So like this, you can go through every box plot and try to understand if there is any pattern related to that variable. Now let's say dates since last order. So for example, for customers which have not churned, you would see that there is lot of variation with respect to dates since last order. but customers which have churned, they are within some range, but there are a lot of potential outliers as well. Now, if you see these data points, these are still potential outliers. We cannot say that whether they are definitely outliers or not. So when you work in the industry, usually what I recommend people to do is you discuss with your stakeholders, discuss with subject matter experts that I'm getting these values in this feature. Do you think it's a value which is expected, or it's kind of an anomalous value? Then you can try to remove it. So on the categorical side, basically we have these three features: preferred payment mode, preferred order category, and marriage status. And on the numerical columns, we have multiple columns which are going to provide us information. So this is the data we have. So if we see now this data frame, all the columns are in the form of numbers apart from these three columns on which we would have to create dummy features, but all other columns are in the form of numbers. So let's create the features from this data and let's divide our data into train and test set. So I'm calling train test split and features function over here. So this is the function basically. So our y variable or the value that we want to predict would be churn, and our x variable or all the features would be in our df features data frame. So I'm dropping churn column from that because obviously we shouldn't use the column that we want to predict as feature. And then we are applying the get dummies function basically on the data frame that we have. So what this would do is this would convert our data into a dummy feature specifically for the three columns for which we want to create dummy features. And after that, we are just doing the train test split. So this would split the data into training set and testing set. So training data we would use for training the model, and test data we would use for evaluating the model. So after we do this, this is how our data would look like. So if you see, the numerical columns are as it is, but the columns for which we wanted to create a dummy variable, so we have created that dummy variable. So this is preferred payment mode UPI, preferred order category fashion, here preferred order category grocery. So we have created the categorical variables based on the specific category that we had. So we are now left with 28 features because we have created additional features based on every category column that we have. So if we check the training data frame now, if we check the top 10 rows, this is how the data is looking like. So all the data points are in the form of numbers. So basically our data is now ready for training a machine learning model. Okay, so what I'm doing now is I'm calling the fit and evaluate model function, which I have written over here. And to this function, I'm passing our training features, testing features, and then training labels and testing labels as well. So this is our fit and evaluate model function. So we are first of all initializing a random forest classifier. So here we are initializing the random forest classifier. We are keeping max depth 5, mean sample split at 0.01. So this would decide what's the percentage of samples which should be present to decide whether to split the decision tree further or not. Then what's the maximum features we want to use in every node. So we are passing 0.8. So only the 80% features would be used. This is related to feature bagging, and max samples we are using 0.8. So only 80% of the data points would be used. This is related to data bagging. Okay. So basically we are fitting the random forest model now using the fit function, and we are passing our training features and training labels to it. And then based on the model that we have trained, we are going to predict. So we are creating the prediction over here using the predict function. So this would predict for every test data that we have, what is the label, whether the customer is going to churn or not. And after that, we are creating the bunch of evaluation matrix. So basically confusion matrix, accuracy score, classification report. So all those things we are calculating and printing. So based on the results and based on the data that we have, this is the confusion matrix that we are getting. And the overall accuracy of our model is 88.54. So this is class 0, which is related to the customers which have not churned. So for class 0, we are getting F1 score 0.93 and the recall value is 0.95, precision is 0.92. And for churned customers, we are getting 0.62 as the F1 score. So it is not as good as class 0, but still it is really good considering we had imbalanced data. So if you check the churn versus non-churn, So we have almost 5 times customers which have not churned. So only let's say 15 to 18% customers have churned overall. So model is still doing well with the parameters that we were sending and the kind of features that we have. So after you do this, you can try feature parameter tuning as well. So what you can do is you can try different parameters with respect to max depth, mean sample split, max features and max samples, and use grid search CV and see which are the parameters for which you are getting the best results on this data. Now grid search CV is going to try cross validation. So here I am setting CV equal to 5. So this would try 5-fold cross validation. And I am again initializing a random forest classifier here and passing it as an estimator to grid search CV, passing it parameter grid which it should try. So this is the grid which we have created. I am saying cross validation should be 5. So it is going to try 5-fold cross validation. So it would divide the data into 5 data sets, and in every iteration 4 data sets would be used for training and the rest of the data set would be used for evaluation. So you would see all the matrix printed over here. So overall, after we run this grid search code, we can save all the results that we have into a data frame. So what I'm doing here is search.cv results. So this would have all the results for every set of parameters. We are storing that into results data frame, and I'm just sorting the results data frame based on the mean test score. So what is the average score that it is getting on the test data within the cross validation, and I'm keeping it in the ascending order so that we get the top result. So if I scroll to the right here, the top result that we are getting is 0.91 with respect to accuracy, and it is for max depth 10, max features 0.7 and the other parameters as well. So if you want to see which is the best parameter that you are getting after applying grid search CV, what you can do is you can do search.bestparams. So that would give you the best parameters on your data set. So on this data set, the best parameters that we are getting are max depth 10, max features 0.7, max samples 0.0, and minimum sample splits 0.01. So now what we would do is we would use these best parameters and train our machine learning model on complete data, because in cross validation, it was using only 4 folds for training and 1 fold for testing. But now we would use complete training data for training the model based on the best parameters that we have found using cross validation. So this is what we are doing here. We are again now calling fit evaluate model function, which we have written over here. We are calling the same function, but now we are passing the specific parameters which we have found. So we are saying we want to keep max depth 10, mean sample split 0.01, max features 0.7 and max samples as 1.0. So after we do this, this is the result we are getting, and now the accuracy that we are getting is 90.31. So previously the accuracy that we were getting was 88.54, and for class 1 the F1 score was 0.62. Now the F1 score that we are getting is much better. We are getting 0.68 as the F1 score. So after we applied this hyperparameter tuning, we have improved the result. Now when we are working in the industry on such kind of problem, what you can do is you can also change your decision threshold. So this result is based on default probability threshold of 0.5. But you can say that, let's say any customer for which probability is higher than 0.4, that customer has a chance of churn, and then that would help you in improving your recall value. So this is how you can play with the threshold of the probability as well. And after I build the model, I have identified which are the features, which are important features getting used in this particular model. So you can do that using model.feature importances in case of a random forest model. So here I am just creating a data frame in which we are going to store all the feature names and the corresponding importance score. And after I do that, I can just create a plot which makes it easy to read which feature is the most important. So if you see here, the feature tenure, we are getting the highest importance for it. So this is the relative importance of the feature. Then feature complaint is also important. Cashback amount is also important feature. Number of addresses is also important feature. So based on these feature importances, you would know which features are actually contributing to your overall result. Now, if you want to make this better, you can also try other methods like, let's say, SHAP, which would tell you for every individual prediction, which features were important in making that prediction. So you can try that as well. I hope that now you got clarity in terms of how we can use machine learning in e-commerce domain or in any domain for predicting the chance of churn. Now this churn prediction problem is applicable in financial or banking domain as well, because even there you have large number of customers. So wherever there are large number of customers which we want to retain over time, we can use their historical data and build churn prediction model, so that the customers which have higher probability of churn, we can handle them in a better way to increase the customer retention rate. So try to build those kind of problem statements now on your own, and that would give you better confidence. Thanks for watching the video, and I will see you in the next one. Bye bye. I'm very sure that most of you have went to the jeweler and purchased gold at least once in last 10 years or 15 years. So for purchasing the gold or for deciding the price of the gold, the process is bit straightforward. It depends on the carat of the gold and it depends on the weight of the gold. So based on these two parameters, the price of the gold is decided. But if you compare it with the pricing of diamond, it is very, very complicated, because the price of the diamond depends on its carat, depends on its length, width, weight, then its clarity, color. There are so many factors which decide the price of a diamond, and that's why it is very complicated problem statement for diamond industry to identify any diamond, measure its parameters, and then decide what is the right price for that particular diamond. So what we thought is, if we can build machine learning model which takes as input different properties, different parameters of the diamond and tells you what is the right price for this diamond, it would create a huge value for the diamond industry. And if this model can be extended, let's say in the form of mobile app, where you can take photo of a diamond and then that mobile app automatically measures various parameters related to that diamond and then gives you the right price of it, it would be helpful for the customers as well. So in today's video, what we would do is we would use the historical data, we would use some examples related to diamond properties and its price. And using that, we would train a machine learning model which would automatically tell the price of a diamond. Hi guys, my name is Rohit and let's get started with today's project. So at the top, I am importing all the modules that we need. So we are importing pandas, then we are importing matplotlib and seaborn for the visualization. In this particular project, I am going to use XGBoost regression model, and then I'm also importing few evaluation parameters that we need. So let's start with the project. So the data that we are getting, these are the features we are getting in this data related to the diamond. So what is the carat weight of the diamond, then what is the cut, what is the quality of cut, because it also decides what is the price of diamond, because the diamonds which have very high quality premium cuts, they are priced highly. Then what is the color of diamond, then the clarity, this basically measures how clear a diamond is. So we have various parameters related to clarity. Then what is the depth? Then we have a table column which gives width of top of diamond relative to its widest point, because this is also important feature. And then we have length of a diamond, width of a diamond, and depth of a diamond. So these are the parameters which decide the right price of a diamond. And the last column that we have is price. So this is the price of a diamond in US dollars. So what we would do is we would use examples of these diamond properties and its price, and we would train a machine learning model which can automatically tell the right price of a diamond based on its properties. So the data that we are getting is in the form of CSV. I'm reading that data using read CSV function from pandas. And these are the columns we have, right from the carat, cut, color, all the way up to its length, width, all the parameters we have. And then we have the price of a diamond as well as our last column. This is the column, or this is the value we are going to predict using all the features that we are getting. In this data set, we have more than 50,000 diamonds. So we have data of more than 50,000 diamonds. So I think it should be good enough to use this data and train a model which can automatically predict the price of diamond based on these features. So the plan is, once we train the model, if you give it the properties of any new diamond, all these properties, it should be able to tell you the right price for that diamond. So it would help in diamond industry basically in creating fair pricing, right pricing for the diamond. Okay, so using the info function, we can check the data types of the columns, and along with that, how many non-null values are present in that particular column. So the data that we have, it's in total having 53,940 rows. And if you see here, all the values are non-null values and all of them are having the values in the column. So I don't think we have missing value problem in this particular data set. So after you apply describe function on your pandas data frame, you can get to know on your numerical columns what are the different statistical parameters. So let's say the caret value, the minimum of it is 0.20 and the maximum is 5.01. Then the depth of a diamond minimum is 43, maximum is 79 and the average is around 61. Similarly, if you go to price column, the minimum price that we are getting in our dataset is $326 and the maximum is more than $18,000. And the average price of the diamond is around $4,000. This is what we are getting over here. So as I mentioned at the top, we don't have any missing values in this particular data. You can check the sum of missing values in every column using isNA function and then calling sum function on top of that. So you can see here we don't have any missing values in the data that we are getting. So here what I'm doing is I'm just checking the unique values in every column so that we get better clarity about every column, in which column we are getting categorical values, where we might have to create a dummy features. That's why it is good to check this. So in caret column, if you see, we are getting a lot of numerical values. So this column is definitely something which we can use as a numerical feature. In cut column, we are getting unique categorical values, ideal, premium, good, very good and fair. So we would use this column or we would use this feature as a categorical feature. Then we are getting various values in color and clarity as well. So basically cut, color and clarity, these are the three columns where we are getting categorical values. So we would create dummy features out of this when we want to give this data as an input to machine learning model. Then depth is again a numerical column, table is again a numerical column. Then X, Y and Z, these three are also a numerical column. Again, to repeat what exactly X, Y and Z is, don't get confused with X and Y as features and let's say output to be predicted. Here X is the name of feature which is representing the length of diamond, Y is representing width of diamond and Z is representing depth. So it's length, width and depth, and the column that we want to predict is price. Okay, so we can check the outliers on our data using the box plot. So what I am doing is now I'm plotting a box plot for every numerical column that we have, and this we are doing using the box plot function from Seaborn. So here I have basically created subplots, 2x3 subplots, because we are going to plot in total 6 plots. So this would basically create 6 plots in 2 rows and 3 columns. So if you see here, the first plot is for caret. So if we see, the median value is around 0.7 and there are some values which are potential outliers. So what you should do is, when you work in the industry, when you see these kind of potential outliers, you can discuss with the industry experts. So let's say if I was working with the diamond industry on this particular problem statement, what I would have done is I would have spoken with the diamond expert and asked him that, do we expect diamonds to have caret values, let's say in the range of 2 to 5. If they say that yes, the caret values can be in this particular range, then these are not outliers. This is just a statistical outlier based on the mathematical formula. But before removing those outliers or before treating those outliers, always check with your business experts, subject matter experts, to know whether that is actually outlier. Similarly for depth, I would have checked with the diamond expert that, do we expect diamonds to have depth, let's say less than 55, and then based on the input that they are giving, I would make my decision. So you can create the box plots to identify the columns which would have potential outliers, but you should always make your final decision, or you should always call something as outlier based on the domain knowledge. And that's why in data science roles, having domain knowledge or having good communications with the stakeholders who have strong domain knowledge is very, very important for a successful delivery of the project. Okay, so now I am creating a heat map based on the correlation matrix that we are going to calculate. So we are calculating correlation between our numerical features, caret, depth, table and length, width and height information that we are getting. So if you see here, we have these 3 features X, Y and Z, which are representing basically the 3 important parameters related to the diamond, and those 3 parameters are length, width and depth of a diamond. So these three parameters are having high correlation. Now here I don't recommend you to drop the features because they are like having high correlation with each other, because all these three factors, length, width and depth, are important in deciding the price of a diamond. So even if these features have high correlation with each other, I won't recommend you to go ahead and drop any of these features, because again here your domain knowledge is important. If you can go back and ask your SME that do you think that all these three parameters are needed to decide the price of a diamond. If they say yes, there is no need to drop any of these features. Otherwise, you would lose important information which is important for deciding the price of a diamond. Okay, so now what I'm going to do is I'm going to create a train test split on our features. So I'm calling train test split and features function, which we have written over here. This is the function basically. Now in this particular function, our y variable, or the variable that we want to predict, is the price. So we are storing that in variable y, and from our features data frame, we are dropping the price column because we don't want to use the value that we want to predict as a feature. So x basically has all the features now, and y has the value that to be predicted. And here we are creating the dummy features because we have some columns which are in the form of categories. So we are creating dummy features for that, or columns for that, using the getDummies function from pandas. And after we do this, we are creating a train test split. So we are splitting our data into training set and testing set using the train test split inbuilt function from scikit-learn. So I'm keeping 20% data for testing and remaining 80% data for training. So basically using 80% of the examples of diamonds, we are going to train our machine learning model, and on the rest of the 20% diamond, we are going to evaluate our machine learning model. So after we do this step, you can see here additional columns are created. So let's say for cut, we have created column for fair, good, ideal, premium, and so on. So for the categorical columns, we have created basically dummy features here. So in total in our data now we have 26 columns. So this is the data where we have 26 features in total, and this is how it is looking like. So if you see now, every data point or every column is in the form of numbers. So our data is now ready for building a machine learning model. So our categorical columns, we have converted them also in the form of numbers. Okay, so the next step that I'm going to do now is we are going to evaluate and fit our machine learning model. So here I am initializing XGBoost regressor, and then after that we are using grid search CV. So basically we are going to use cross validation to identify which are the best parameters on our data set. So we are using multiple parameters here. Learning rate, which would decide how every subsequent model in XGBoost is going to contribute in the overall result. Because if you know the way in which XGBoost model works, so basically it's a boosting model. So every next model is going to improve the results of the previous model. So this learning rate decides how much every next model is going to contribute in overall prediction. Max depth decides the depth of decision tree which would be built in your XGBoost model. Subsample decide what's the percentage of the data points which would be used at every node for a split. And call sample by tree decides what's the percentage of the columns or percentage of the features which would be used. And n estimators is how many number of estimators or how many number of weak learners we are going to build. So this is the parameter grid, and we are going to try these different sets of parameters on our data using cross validation. So I'm using 5-fold cross validation over here, and then this would tell us where we are getting the best result. And for evaluation, for scoring in this particular case, we are going to use the R2 score as it's a regression model. So after we run this, we would get the results for every cross validation set and what kind of evaluation we are getting. So what I'm doing is, for ease of reading, I'm storing these results in a data frame. So I'm reading it from the CV results and storing it in pandas data frame. And then I am sorting the values in the descending order. So this would give us the best possible result at the top. So in this data frame, basically we have the results for cross validation. So the best result that we are getting has mean test score 0.978. So this is the best R2 score we are getting. And then we have corresponding parameters for it as well. So basically in this data frame, we have which parameters we have tried and what are the corresponding results. So let me scroll to the right. Basically the best results we are getting for call sample by tree 0.8, parameter learning rate 0.3, max depth 5, number of estimators 50, and so on. So using cross validation, you can know that for different sets of parameters, how your machine learning model is performing. And Please remember that cross-validation is applied only on the training data, okay? So on training data itself, it is going to split the data into 5 sets based on the CV equal to 5. And 4 sets would be used for training and the last set would be used for evaluation every time. This is how cross-validation works. So using search.best params, you can know which are the best parameters on this particular data. So these are the best parameters we have found on this particular data using cross-validation. Now the next thing that we should do is we should train the model on complete dataset, on complete training dataset. So this is what we are doing now. We are creating a XGBoost regressor, giving it a parameters which we have found as the best parameters using cross-validation. And then basically we are training the model on complete training dataset. And after doing training, we are going to use this trained model for predicting the prices of diamond based on our test features. So we are doing that prediction using model.predict. So using predict function, we are predicting the prices of diamond and the input to it is our test features. So we are storing the predicted values in XGBpredict variable. So after we do this, we can calculate the R-squared value, which is used for evaluating the regression models. And that expects your original label, the y-test values and the predicted values. So if you pass it, you would get the R-squared value. Now in this particular case, we are getting R-squared value around 0.98. So this is really a value which is near 1. So we can say that the model that we have built is able to predict the diamond prices accurately in most of the cases because we are getting very high R-squared value. The ideal value for R-squared value is 1. So the value that we are getting is near to 1. So we have created very high quality machine learning model which can predict the prices of diamond. And the mean absolute error we are getting in this particular case is 310. So we can say that this model would predict the prices accurately, but on an absolute term, there would be error of $310. Now this is the metric your business stakeholder would understand better. Business stakeholders won't understand the R-squared value. This is for you as a data scientist to know the quality of your machine learning model. But when you speak with the business stakeholders, they would understand only the numbers, let's say in the form of money. So here you can say that the mean absolute error that you're getting is $310. Or they can also identify or understand the percentage error. So you can say that the percentage error that you're getting in your machine learning model is around 9%. So these are the parameters your business stakeholders would understand, and R-squared score is for you as a data scientist to evaluate the quality of your machine learning model. So the model that we are getting is having absolute error, mean absolute error in terms of percentage around 9%. So it's not that bad. It is giving a right kind of a value for every diamond that we have. Now, after you build the model, if let's say stakeholders ask you which features or which parameters were considered by your machine learning model for deciding the price, then you can also answer that question by getting the important features. So using model.featureImportances, you can get the important features from the XGBoost model, which were used at the time of training for deciding the price of diamond. So based on this, what you can do is you can get the important features, store it in the form of data frame with a nice structure so that the results become really readable. So I won't explain this line by line because I think this is very straightforward. So if you see here, the first column that we are getting is the importance of the feature and the next column is the feature name. So, and I have sorted this data frame in the ascending order. So the least important feature is cut premium and the most important feature basically is our Y value, which is telling the dimension of the diamond that we have. And you can also create a nice visualization for this. So using a bar plot, you can plot your feature importances. And this is saying that, okay, the dimension of the diamond, basically Y and Z feature is very important in deciding its price. Then what is the carat of the diamond? It is also important. The clarity of the diamond is also important feature. So using this feature importance, you can better communicate with your stakeholders that which features were used in deciding the price of a diamond. But ensure by that or make sure that you understand that this feature importance is based on the training time feature importance. If you want to know for every prediction that you're making which features were considered, then you would have to use some localized method like Lime and Shap for getting that kind of importance. This is a global feature importance at the time of training. Right. So this is how we have built a machine learning model which can take important parameters, important features related to the diamond, and then based on that predicts its price. Now this kind of a model would be very, very useful for the diamond industry. Now what I want all of you to do is take different datasets from Kaggle and build similar kind of regression models. That would help you to gain confidence in problem solving, and you can also add those projects in your CV. Thanks for watching the video, and I would see you in the next one. Bye-bye. For any pharmaceutical company, it is very important to understand what is the review of their medicines when their medicines are getting used by the patients. So if they collect the information about their new medicines and how is the response of the patients, are those medicines actually solving their issues, then it would really help the pharmaceutical company to improve their medicines and come up with better combinations. Hi guys, my name is Rohit, and in today's video, we would build a classification model on the medicine review data, and let's see what kind of things we find in this particular data set. Let's get started. So here at the top, I'm importing all the modules that we need. So I'm importing pandas. Then from scikit-learn, I'm importing the matrix for the evaluation of classification model. So this model we are going to build using XGBoost classifier. Then in this data, it's a text data. So I'm going to convert that text data into numbers using a TF-IDF vectorizer. And then we're also importing some other modules that we need for working on the text data. Okay, so I'm reading the data using read CSV function in pandas. This is the data we have. So in our data, basically we have two columns, a review column and a label. So if you see here, every row basically has a review of a medicine and a corresponding label. And the medicine can be of different category. It can be for depression, pain, anxiety, any kind of issue that a patient is facing. So let me show you some example of the review. Okay. So this is the first example, basically this one. So for this review, the label given by the patient is positive. So it's a positive experience patient is having. Now what is the review? I have taken antidepressants for a year with some improvement, but mostly moderate to severe side effects, which makes me go off them. I only take Cymbalta now, mostly for pain. And what the person is saying, I noticed a major improvement overnight. More energy, better disposition, and no sinking to the low loads of major depression. Best thing, no side effects. So basically this patient is having a positive experience. So the label that we have for this particular review is positive. Then the next review that we have is this one. My genius psychiatrist started me on this drug in the fall of 2008. So basically, and what is the outcome basically? In retrospect, I wish I hadn't taken either fluoxetine or Seroquel. So basically, the patient is not having a positive experience on this particular drug or on this particular medicine. So the review or the label for this particular review is negative. So we have a negative label for this particular review. So this is the data we have. So we have information about the review of a customer and a label. Now, if you imagine if the company starts collecting the review of every patient, right? For them, it is very difficult to automatically understand which review is positive and which review is negative. So if they label just few thousand reviews and then if they train a machine learning model on that review data, then any new review that they would receive, they can automatically classify that review into a positive or a negative review and then accordingly take action on it, because the company would be very, very interested to know the negative reviews and what kind of side effects people are having after taking those medicines. So what we would do is we would take this review data and we would train a machine learning model which can automatically tell based on the review data whether this review is positive or negative. So in total, we have more than 12,000 reviews in the data that we have. So here, first of all, I'm reading the list of stop words. So the data that we have is in the English language. So I'm reading the list of English stop words and then all the punctuations. So we are going to exclude all these punctuations. So I'm just reading both the things over here. So this is the list of standard stop words within English. So the words like I, me, my, we, our, these words are not providing any specific information about the review. So these are the generic English words which we can see in all the reviews. So what we can do is we can remove those words from our text data. That's why I've saved all these words in a variable stop words. And then we would have to remove all the punctuations as well. So these are the punctuations which we are going to review from our data. So if we see any such punctuations, we are going to remove from that data in the data cleaning step. Okay. So I would explain you all these functions. So what I'm doing is, on the data frame that we have, I'm calling a text data cleaning function. So once I call this function, it would come here. So in the text data cleaning function, we are doing data cleaning step by step. So first of all, I am creating a new column with the name review original. And in that column, we are keeping our original review, so that after cleaning the text, we can still get to know what was our original review. So that's why I'm keeping that review over here. Then we are converting the data that we have into a lower text format. So in a lowercase format, using the str.lower functionality. Then after that, I'm applying a function for removing punctuations. So on the column review, I am applying a function for removing punctuation. So this remove punctuation function, what we have written in it. So basically what we are going to do is, we are going to remove the punctuations. So any punctuation which is present in this particular list, so anything from this would get removed from our data. Then we are removing the stop words. So I'm calling a function for removing stop words. So what's the logic written in this function? So this is the function for removing the stop words. So what it would do is, it would basically split the text that we have, and it would take only those words which are not present in the stop word list. So basically, I am taking the word for every word present in our text after splitting that text, only if that word is not present in the stop word list, because we want all the words which are not stop words. And then we are returning the data by joining all the words. So this is how we are removing the stop words from the data that we have. Then after that, we are applying stemming. So we are calling a function for applying stemming. Now what's happening in the stemming? So here, first of all, we are initializing a stemmer. So I'm using a porter stemmer for that. And then this is the function for applying the stemming. So for every word that we have, we are going to apply a stemming. So stemmer dot stem, and then pass the word for which we want to get the stem version. So this we are going to do for every word in our review. So using the text.split, we are going to split our text into words, and then on every word, we are going to apply stemming. So stemming basically reduces the words to their base form. Then after that, we are also applying lemmatization. So lemmatization also reduces the words to the base form, but there are some words which we are not able to handle using stemming. So even, let's say, there are certain examples where it's a grammatical stemming, right? So that kind of thing, stemmer won't be able to handle, and that's where we need lemmatization. So lemmatization can reduce the words to the base form, even if they are not in the simple format. So for example, in stemming, if you get something like eating, it can reduce it to eat. But let's say if you get something like good, better, best, so that kind of format, stemmer is not able to understand. But lemmatizer understands that good, better, best explains the same thing. It's just a different way in which we are expressing the words. So that's why we are going to use a lemmatizer. So we are initializing the word net lemmatizer over here, and the same lemmatizer we are going to use for reducing the word to their lemmatized format. So here what I am doing is, lemmatizer actually needs the word along with that a part of speech as an input. So by default, I am keeping part of speech as verb, because most of the words which we would reduce to their base form would be in the form of verbs. But if you want to improve it further, what you can do is, you can detect the part of speech of every word, and then accordingly you can pass the corresponding part of speech over here. So basically we are applying all the steps for cleaning the data. So we started with reducing the text to the lowercase format, then we removed all the punctuations, we removed all the stop words, and after that we applied stemming and lemmatization. So this would give us the cleaned data. So after applying the function, I am calling head df.head to check the first 5 rows of the data. So if you see here, now we have 3 columns: review column, label, and the review original. So this is our original review. And this column basically has the data of where we have cleaned review. So let's see how the cleaning is exactly happening. Example of it. So this is our first review, right? Where the patient is writing about the review of a depression related medicine. So this is the original data, and this is the data that we are getting after cleaning it. So if you see here, we have removed the punctuations basically. Then we have removed the stop words like I. If you see, depression is reduced to depress because we are applying stemming and lemmatization. Taken has been reduced to take. Then years has been reduced to year because stemming would reduce it to the base form. Then when we apply stemming and lemmatization, sometimes you might also get some weird words. So for example, improvement, it has reduced to improve. Okay. So these kind of weird words can also happen. But if you are going to apply, let's say TF-IDF vectorizer on this data to create a features, then it's not going to create any impact because all these improvements or any words which are improvement in your whole text data, all of them would get reduced to improve. So it's not going to create any impact on the quality of the results. But on top of this, if you are going to use any pre-trained word-to-vec model, then you have to be very, very careful while applying lemmatization and stemming. The label data that we have, I'm mapping a negative label to 0 and a positive label to 1 because we'll have to use it for training our machine learning model. So in the data that we have around 9,000 reviews which are positive reviews and around 3,000 reviews which are negative reviews. So on this data, I'm going to use TF-IDF feature extraction. So I'm keeping the first 10,000 reviews for training and the remaining reviews, so more than 2,000 reviews for the testing. So on this 10,000 reviews, we are going to train our machine learning model, and on the remaining data, we are going to test the model. So the first function that I'm calling is TF-IDF features fit, and to this function, I'm passing our training data. So this is the function basically. So in this function, I'm initializing a TF-IDF vectorizer. So TF-IDF vectorizer is the one which would consider the frequency of occurrence of the words in the document in that particular review, as well as across all documents, across all the reviews. And based on that, it would convert every review text that we have into a numerical format. So I'm giving min def as 0.01. So the word has to be present in at least 1% document, and the max df as 0.1. So if any word is present in more than 10% document, we are going to remove it. This would help us in reducing really infrequent words and words which are occurring frequently across the document, because we want to focus on the important information. So here I have initialized the TF-IDF vectorizer, and after that what we are doing is we are applying fit transform on our training data that we are passing. So here I am passing only the training data. So on this I am applying a fit transform. So this would basically convert our text data into a numerical data into a TF-IDF matrix. And then I am just returning the TF-IDF vectorizer along with the feature matrix that we have. Then here I am getting the list of all the features using get feature names out. So this is the default method that you get within a TF-IDF vectorizer. So I'm using that to get the names of all features which we are creating using TF-IDF vectorizer. So these are the features which we are creating: 05 mg, 15 mg, then actual, addict, adjust, effect, bring, breakthrough. So basically every unique word in our document after doing data cleaning has been converted into a feature, and it would also have a weight which would be assigned based on the TF-IDF weight. So in our data, we are having 546 features. And this is how your feature matrix would look like. So here I am just checking the first row. So most of the features would have value 0 because TF-IDF feature would have value only when that word is present in that particular review. So here, for example, this word, it has TF-IDF weight 0.232. Then there is this another word which has TF-IDF weight 0.175. And most of the words which are not present in the document, they would have TF-IDF weight equal to 0. Then similarly, we are applying a transform on the test data. So I'm calling another function TF-IDF features transform. And to this function, I'm passing our TF-IDF vectorizer along with our test data. So if you check this function TF-IDF features transform, so we are applying basically a transform on the review data that we have from the test. So one thing that I want all of you to remember is whenever you are using a TF-IDF vectorizer, apply fit transform only on the training data, and on the test data, you should only apply transform function. This helps you to create a similar kind of an environment which is there when you deploy your model. Because in the deployed models, the reviews that we would get in future, your TF-IDF vectorizer, it won't be able to see it. That's why when you are testing the model, apply transform on test data and fit transform on the training data. This is very, very important, guys. Okay. So then I'm calling a train test split function. So we would have to split our data into train and test. Specifically, we would have to split data into features and labels. So this is the function that we have written. So here we are creating a variable yTrain, which would have the label information of the training data, and variable yTest, which would have a label information of the test data. So we have created a training and a test label. And similarly, I'm creating xtrain and xtest, our training and test features from our training and test matrix that we got from TF-IDF vectorizer. So basically now we have converted the data in the form of numbers. We have a training data and test data. We can now go ahead and fit a machine learning model. Now you can use any machine learning model, but generally in the industry right now, XGBoost is the go-to machine learning model for most of the problem statements. So I'm calling fit and evaluate model function over here. And to this function, I'm passing our training data and testing data along with features and labels. So this is the function basically. So over here, I'm initializing a XGBoost classifier, and then we are fitting a model using fit function, which is a default function for XGB classifier. And to that function, I'm passing our training features and training labels. So this would basically fit the machine learning model, train our machine learning model on the data. Then using a predict function on test data. So I am now applying a predict function on the test data, and I'm using the same machine learning model which I have trained to predict the label on our test data. And after we do that, we can create a bunch of evaluation matrix. So I'm getting a confusion matrix over here. So for confusion matrix, you will have to pass your original label along with the labels that you are getting after prediction. Then I also want to calculate the accuracy score. For that also, I am passing the original label along with the results that you are getting after prediction. These are the results basically. And then I am also displaying the results. So I am displaying our confusion matrix and accuracy score. And along with that, I am also creating a classification report, which would give us complete idea of precision, recall, and F1 score across the classes. So this is how we have trained XGBoost classification model on our test data, on our training data. Then we have applied on our test data to create a prediction. And then we are creating a bunch of evaluation matrix. So one thing that I'm not doing over here is I'm not doing hyperparameter tuning. But for you guys, as a practice, what you can do is you can try hyperparameter tuning and see whether you get better results than the default parameters, which I am using. So this is the result that we are getting. So this is our confusion matrix. So, and the accuracy that we are getting in this case is 89%. So for class 0, which is our negative class, let me check whether class 0 is a negative class or a positive class. Yeah, so we have mapped negative to 0 and positive to 1. So class 0 is our negative class and class 1 is our positive class. So for class 0, for the negative class, the recall that we are getting is 0.65. It means that 65% of the negative reviews we are able to predict correctly that this review belongs to a negative review class. And this is happening because, see, the recall, if you see for class 1, it is 0.97. And overall F1 score for class 1 is 0.93 and for class 0 it is 0.74. The reason for this is most of the data that we have belongs to class 1. So again, to improve this result further, what you can do is you can give higher weight to the examples of class 0. So there is a class weight parameter within XGBoost classifier which you can use, or you can do upsampling of the class 0 using something like SMOT, and that would also help you to improve the results further. So all these things you can try to improve this machine learning model. But even with the default parameters, we are able to get accuracy of 89% and F1 score of 0.74 for class 0 and 0.93 for class 1, which is not at all bad. Now with the XGBoost model, we can also get the important features. So I am calling a function get important features over here. And to this function, I am passing our model, which we have trained along with the list of features. So this is the function that I have written. So in this function, all the feature importances, I am storing them in the form of data frame. So from XGBoost, you can get all the feature importances using name of the model. So basically model is the variable in which I am storing our XGBoost model. So model dot feature importances. So this would give us all the features and their corresponding importance score. And I am just storing it in a better format. so that all the importances are in the ascending order, all the importances are in the descending order, so that we get the features with the highest importance at top. So after we do this, we would get a data frame like this. So here we have importance column and a feature column. So for every feature, we are getting what is the relative importance of that feature. So for example, feature worst, its importance is 0.021. Then feature worse, its importance is 0.019. Then horrible, vomit. So if you see, these all are negative words. So if people are facing issue after taking medicine, they are suffering. So these are all examples of negative words. So basically in this particular problem, any kind of a word which would help our machine learning model to separate a negative and a positive class, that word would come up as the important feature in this machine learning model. So these are the top 20 important features that we are getting. So if you see here, most of these are negative symptoms, like after taking the medicine, people are getting diarrhea, people are getting nausea. So all those kind of issues people are facing. And similarly, if I check the last 20 features, so features with the least importance, so there are some words like, let's say, case, real, enough, reason. If you see these words are not providing any information about whether it's a positive review or a negative review. That's why these words were not used by our XGBoost models. It was not used by the decision trees which are built behind the XGBoost model. That's why their importance is 0. So what you can do as a next step is you can remove all the features from the data now, remove all the features from your machine learning model where you are getting feature importance equal to 0 and retrain your model. Because at the end, we want to create a model which uses only those features which are providing useful information. If these features are having 0 importance, it means that those features are not getting used in any decision tree. So there is no point in using those features again in terms of training as well as in terms of prediction. So we can remove those features from our data and retrain the model. Right. So if you see the result, so we are able to solve the problem statement that business had. We are able to now tell any review that we are getting from the customer, whether it is a positive review or a negative review, using the machine learning model that we have trained. So let's say that now the company starts a huge kind of exercise where they start collecting review from lakhs of customers, right? Then using this model, they can automatically know which reviews are positive and negative, and then start reading the negative reviews and start taking actions based on those. Right. And apart from this, whatever steps I have told you throughout this particular project, so I want all of you to try hyperparameter tuning. I want all of you to try class weight parameter for better data balance, try SMOT as well, and also try to remove the features which are having 0 importance. Try these things and let me know in the comments what kind of results you are getting. Are you able to improve this model further? And let's see who comes up with the best model. Thanks for watching the video, guys, and I will see you in the next one. Bye-bye.